It's a great pleasure to be here today. I'm just going to share a little bit, a few examples when we went through our journey in analytics. Analytics is not easy. When we talk about analytics, first thing people think about often will be around running analysis or building a model. That's certainly true. Running analysis properly and building good, solid models are critical to our mission. But we need to do much more to enable analytics in a large corporation. We need to secure support from the senior executives. We need to help others around us to get used to analytical thinking and make data-driven decisions rather than just based on intuition experience. We also need to hire the best data scientists. That's not easy. And it's not any easier to keep them around and motivated. Those are all very challenging. Analytics brings a lot of changes to an organization. And to push through those changes takes a lot of effort. We need to acquire internal data sources, often which is not readily available or not in good shape. Not to mention how to integrate those with external data seamlessly. And our challenges does not finish when we finally have a very good model in the lab. We need to take that model into production. We need to make sure, it's very important, make sure the business owners fully understand what the model does and what not. We need to interpret the results properly. And also we need to work with IT to go through all the challenges in production. And finally, we need to monitor the performance, make sure the model works as expected, and we'll refresh it and make adjustment as necessary. So all those challenges we face come with many pitfalls. We certainly don't have time to go through all of them today. I will just use 4 examples from the different stages in an analytical project. We'll talk about when defining a problem, when we're collecting data and massaging the data, when we run analysis, interpreting results, and when we put the model into production, implementing. It is human nature to solve problems with your most familiar tool. A modeler often tends to treat every problem as a modeling problem. But that's not always the case. And similarly, others who work with us, when they see a model in the room, they tend to fall into the same trap. So here I'm going to share a story from a friend, Marina. When she worked on auto insurance pricing in Thailand, she once received a request to build a simplified version of the model that was used in production today. The current model used in production, loss cost model, has dozens of risk factors and hundreds of levels. And they want to cut it down, make it simpler. Marina had a very strong modeling team. Sure, no problem, right? They can build a very good model with less complex structure. But she asked a very important question. Why? Why do you want a simplified model? Does anyone want to make a guess? Sarah couldn't hear? Yes, that's a very good point. I've seen that too. Yes, yeah. And also there could be regulatory restrictions. Right? There are many reasons. And in this case, it turns out the pricing tool used in Thailand was very ancient. They used a spreadsheet. So the brokers literally had to go through dozens of tabs in the spreadsheet, look for the values of the risk factors in every tab, and input the value into a final tab, into a formula to get a price. It's very tedious, very time-consuming, and error-prone. So in this case, do you think a simplified version of the model is the best solution? I very like the fact that we as modeler can ask such questions and bring that on the table. So essence from this example is we should always keep the big picture in mind. Often, a new model is not necessarily the best solution. We need to think, is it easier and cheaper to change the process, to bring in a new tool, or to train our participants? We love analytics, but if there are easier ways to solve the problem, we have no doubt we can put analytics aside for a moment. The second pitfall I want to talk about is around trusting the data. We live in a fast-paced world. People hate documenting stuff. The data dictionary you receive, can you really trust it? And sometimes, do you have the time to read data dictionary line by line, word by word? Not to mention, in some cases, you never even get a data dictionary. So, what do? We have to check for ourselves. In this example, we encountered using telematics data. Oh, by the way, how many people are familiar with telematics? Please raise your hand. All right, not so many. So let me spend a little bit of time to explain what it does. Auto insurance companies can use telematics technology to record the data from GPS and a few other sensors. It can be either from an app in your smartphone or from a little device plugged into your car. When we receive those data recorded, then the insurance company can build a model to predict, are you a more safer driver or more risky driver? If the model predicts you are safer, you may get a discount in auto insurance. So in this case, when we receive the data from a vendor, we found some drivers, they have much more trips than a normal person would have. So what's going on? Actually, that's Man's team in our group. They put the data into a map. So as we see here, the red dots are the endpoints of the trips. The blue line or a green line, those are actually many, many dots of the GPS points recorded for those trips. So we see this person had many stops along the same road. Why would a person make so many stops? So we took a closer look. Guess what we found? Those stops align very well with bus stops. So we guessed, right? The vendor gave us the data, but they couldn't weed out the bus rides. Now we're evaluating our policyholders based on their bus drivers' behavior, not their own behavior. Right? That's not fair. So Man and the team developed an algorithm to remove the bus rides from our data so we can use it properly. Such many data issues are easy to detect, but some are not. One clue we can see is look for those too good to be true results. I recall in my early days when I was still a modeler, I worked on a project building a retention model. The first result came out unparalleled, really, really good. I knew I was a very good modeler, but not that good. So I checked the model again. I found the strongest predictor is called payment method. People who use the payment method of ACH had much higher retention rate. They're more likely to stay with the insurance company. That's quite intuitive, right? You use ACH, you forget about it, you never think about it, so you don't switch. But is it really that strong? After many phone calls and talking with a few experts who started collecting the data from the very beginning, and they knew the history, I learned that this variable was not collected at the beginning, was only collected in the middle. So for those people who cancel the policies early, they never got ACH payment method. That makes this variable a priori. So you cannot use this variable in the model. So these kind of errors, we have to be very careful because it gave us a false high performance. We think the model performs really well, but it is not. Such data errors can be more harmful, so we have to be very alert and watch for any signs. Just as Mark Twain said, it ain't what you don't know that gets you into trouble. It's what you know for sure that jumps out so. We have to stay alert and always keep an eye on it. Here's the third pitfall. We are lazy. We often tend to use what's available conveniently to do our job. But that will cause problem. I'll use another telematics example. We observe that people who are enrolled in telematics programs, they tend to have lower accident rate than the others, right? So the belief is telematics feedbacks help improve driving risks and reduce losses. When we want to measure the impact of telematics, can we just use the difference between these two groups? Not really, because there's a complication. People who adopted telematics program, they tend to be safer drivers to begin with. So we're looking at the combination of two effects. So what do we do? Instead, rather than comparing these telematics versus non-telematics groups, we randomly split telematics group into two. In one group, we gave them feedback. The other one don't. So this way we have a clean control group. Then we can more accurately measure the incremental impact of telematics. The point here is we should not subject all our customers to the best practice. We should leave out some one more slide. We should leave some out in the old way. That way, we have a segment provides monitoring control group for the current decision, and it also help us get data for future insights and actions. Last but not least, I want to talk a little bit about being practical. We may build very good models in the lab, but they are not always working in reality as we thought. This is my favorite example. BR limit, or bodily injury limit, is known to be a very significant predictor of auto risks. BR limit is really the maximum amount an insurance company will pay if you run into an accident, you hurt other people. Right? That's the expense will cover the medical expense, and etc. Every state is required by law. Every state has a different minimum limit. We have proven that customers who select the state minimum required by law, they are significantly more risky than those who elect to buy higher coverage. That's intuitive. People who are more responsible, they want more protection. And this one is very predictive in loss model. But now the question is, can we really use this model in reality, in pricing? Can we charge people less when they choose a higher BR limit? No, because if we do so, everyone will choose a higher limit. That will destroy the model. So this is a very classic example in insurance. What we see in the lab may not be used in reality in production as is. I have, there is another example. Many years ago, my team built a Mockney response model. Right? We were playing with modern machine learning techniques. We used random forest, built a very good model, much better than the typical logistic regression. So we took the model to our IT and said, hey, we have this great model, let's build it. And the IT guy asked, how many predictors we have? We said, 1,000. It's going to take a year. So at that time, our production team was using the old-fashioned scorecard to build models. With random forest, you have thousands or hundreds of variables and hundreds of trees. It's going to take a very long time to build. We ended up downsizing the model, using the insights from random forest to build logistic regression again with only 15 or 20 attributes. But that incident started our effort to automate the process going to production. So we work with IT. Going forward, when we have a model, our code can produce certain documents, and IT have their script to read documents and automatically generate the production code to run the model. So those kind of things we have to include at the very beginning, even before you start modeling, like the BR limit example. Right? Before you invest all the effort in modeling, data cleaning, understand regulatory requirement. There are some attributes you cannot use in some countries or some states. You need to consider PR concerns. Some attributes are not very good if you use that to separate people. And also there are cultural, environmental differences. In some countries, things are very different than what we see typically in the US. So all those effects we have to be mindful before or during the process of modeling. We have to consider them from the very beginning. So in summary, we went through a few examples, and the known pitfalls are just the tip of the iceberg. With so many challenges we're facing today, there are many more pitfalls we are not aware of. We have to keep the watch. We have to be very alert. Steve Jobs advised students a few years ago, stay hungry, stay foolish. For us analytics professionals, we need to add, stay suspicious. That's the end of my presentation. Any questions? Yes?
Could you describe some of those challenges that you faced, and how did you kind of overcome some of those challenges? Because there are like different systems, different sources, etc.
Yeah, sure. I won't go into any details because they didn't go through our PR. But I've seen in my long career, in early days, when I worked with my first client, a very large insurance company. Their data sits in a system developed in the 70s, written in COBOL. Nobody dares touch it. Why? Because who knows how to do it? It's gone. Right? So what they did is they just read from the system all the data, translate those into new system. It's going to cost a lot of money, effort, right? And then use data only from the new system. Keep the old system intact. AIG has a very unique situation. It's a global company. We are in many, many countries around the world. We're not very big in many countries, pretty small. That gave us a unique challenge because every country may have a different IT system. The systems don't talk to each other. And even when they do talk to each other, the data formats are different. The attributes required by local governments are different. One variable, like gender, we can use that for pricing in the US. It's not allowed in Ireland. So one of the challenges I mentioned is how do we integrate internal data and external data sources? Those are very hard. I think it's, in my opinion, it's even harder than building a good model. So what we did is we took the bare minimum, the common denominator of those, and another team built a system in a reporting structure. They're not perfect. They don't reconcile with every system, but it's usable. So I guess to answer your question in a simple sentence is we use what we have. We try to find the most common ground. Yes?
When it comes to transitioning your models to IT, how do you overcome the issue of IT not having the proper infrastructure and also the IT personnel not having the proper kind of technology stack that you use to build a model?
Do you really want to get me started in IT? We have a fantastic IT team, but they have a lot of things on their plate. I guess in those situations you just mentioned, number one is we need to get senior support. We need to get the budget. IT costs a lot of money. Some even say they get paid higher than data scientists. I don't think so. But we need to push the resource to invest into the system. And also we need to find, I guess, in many cases, find some compromise solution. When we can achieve 80% of the goal with 30% of the effort, we go for it.
Any other questions?
Yep, here at the front.
Okay.
Can you touch about the explainability of the model versus predictability? Insurance is so regulated. Can you repeat the question?
Yeah, the question is the difference between explainability and predictability of the model, correct? In insurance, we have, I guess in the US and in many other countries, is very tightly regulated. When we build pricing model, loss cost model, we have to go through government approval process. We need to take the model to the State Department of Insurance and show those actuaries or non-actuaries, say, hey, we're going to use age, gender, and to rate our customers. They will say, show me the actual evidence. Right? To do that, we have to build very simple, easy to understand model. I think we got a common prior. We have to make the model easier to explain, right? You need to simplify the model. So in that case, we may lose some of the prediction power, but it is the reality. We have to suffer that. What we can do is we use more advanced technology like gradient boosting to build a best performing model, help us to identify the best transformation, the best combination of the predictors in the logistic regression or other GLM models, which is easier to understand, easier to explain to the government, the regulatory officials. I suspect, I hope, in the next few years, when more and more people understand data science, those professions, those people in this sitting in the government offices, when they have better understanding of GBM, random forest, or chatbot, we'll be able to use more complex models. Yes?
So you raised the question that when the model performance is too good, then it may not be true. So what if the model performance is not that good? Will you trust it more than a good performance model? What other factors will trigger your suspicion? Thank you.
I guess when the model performance is too good, right, you will see it. I mentioned that example because it's human nature where you see, great, I built a fantastic model. You want to put rush and put sensor production. So I use that example. We certainly see there are cases when there's issue in the data, the model is not performing very well. Actually, just in the recent case, we see a score provided by a vendor actually is not performing very well. Then we were suspicious, and when we look, and we found actual issues in the data. So I guess the gauge is now more experience-based rather than science-based. We just, based on our past experience, what we've seen in this line, with this kind of data, there's a range of performance you expect. If you see something doesn't look like right, it's not as good, it shouldn't be that bad, you will have the feeling you will go back to check. I'm not sure whether any audience have a more systematic way to check this. I'd love to hear any other thoughts. For now, what I use now is just more based on experience. Talk to people, like, man, our best modeler. Leverage the past experience.
Can you talk a little bit about how do you grow your data science team with all those new like open source technologies, right? How do you keep your team updated to the new things, especially insurance? We have a lot of people, work with the legacy system. How do you battle between the two?
Yeah, that's a very good question. I guess short answer is we go to ODSC. So what I do is here, we have a data science team, and we're hiring. And also, we bring our team to different countries. Yeah. So I think for our data scientists, we are truly curious. We always look for challenging projects. So one key factor, of course, we need to work on compensation, logistics, all those kind of things. But one key factor is we need to make sure the team has enough challenges. We don't work on those easy work, right? For some, we may use those as training projects, but we need to give the best performers the hardest problems to solve. In my opinion, that's the best way to keep the team engaged. Yep.
I'll actually jump in there for a second. My last startup was a machine learning startup in Cambridge, and we would pick a paper. It's just something that anyone could do if you have a small enough team. We would pick an academic paper, some sort of research related to some aspect of machine learning, preferably something that had something to do with what we did, but not always. I mean, when the AlphaGo Zero paper came out, we picked that paper, and someone on the team presents it to the rest of the team. We would do this at like 5:30 on a Thursday with beer and pizza. And every week, someone is picking a new paper, reading it, summarizing it, presenting it, sitting around talking it. talking about it, and it's a good way to just keep your team's finger on the pulse of, the latest developments in machine learning research.
Yeah, having that culture within the team, data science needs to talk to each other, right? We always learn from each other, from bouncing ideas off each other. That's a great point. Yeah.
All right, maybe one more, and then we have a coffee break coming up, which is good. It's always good to get some good caffeine in the afternoon. Any final question? All right, well, as I predicted, some very useful, hands-on, applicable, real-life advice. Thank you very much. Really appreciate it.
Thank you.